Hello and welcome to the first video in a new little series, building a VTOL. Yes, a VTOL, we're back to that. Now, in 2023, I spent a lot of time trying to figure out hobby grade VTOL that had the tilt rotor style of setup. Things like the Hewing T1, things like the ZMO Pro, and to be blunt, they were all fraught with lots of issues. And a VTOL has to be able to do four things really well. It has to be able to fly well as a plane, it has to be able to hover really well as a multi-rotor, it has to be able to transition to forward flight, and it has to transition from forward flight. And surprise, surprise, if you get any one of those four things slightly wrong, then you get disaster. I think lots of us found that out. Lots of manufacturers are making a really poor job of setting everything up. In fact, I did that video at the end of 23 where I said, you know what, I'm kind of done with this whole thing for now. However, enough time has passed and I'm feeling a little bit less annoyed about the whole thing, and I'm back with Ben up at 3DXR, and Ben offered to do an updated VTOL build doing a 4+1, which is what I would recommend if you're going to build a VTOL, not a tilt rotor. Tilt rotors are notoriously difficult to set up, but it's been a while since Ben and I did that original series and a lot has changed. So it's an opportunity to go through and for Ben to show you the pieces that he uses, the process, and even in the last video, a tuning video. Yep, we're going to get a tuning video as well. So we're going to go from this selection of parts on the desk to a fully tuned flying VTOL as part of this. So if you're interested in VTOL stuff and you want to have somebody who's an expert can take us through it, you're in the right place. Be aware that the stuff that Ben is going to use is professional grade stuff. He's going to use a Pixhawk Cube. I would recommend using a H7 based flight controller. One of the higher end Maytech wing boards would be fine for something like this. Obviously, Ben is going to use the Cube. That's the thing that he knows and loves the most. The reason that H7 is really important is because that allows you to run Lua scripts to do the tuning part, which will be the end of the video. So if you deviate from the stuff that Ben's doing, you know what? You might not have the same outcome, but I think it's a real great opportunity to have Ben show us how he does it, because he's built literally dozens and dozens, probably hundreds at this point of VTOLs, and he can pass on to some knowledge. So enough of me banging on, this is going to be long enough as it is. Let's go over to Ben, and in this video he's going to go through all the different pieces and more specifically why he has chosen those pieces for this particular build.
So I featured this aircraft in a few other videos looking at setting up VTOLs and showing you some of the features available to autopilot and VTOL setup. What we want to do in this series for 2024 is to show you the setting up of the flight controller. So what is the latest sort of settings we'd use, software, what's the latest hardware, what sensors we're going to put in there, and then we're going to tie that into this VTOL build, which is, you know, what features are now available in VTOLs and how would I do it today, even though I've been building this particular model for probably 3 or 4 years. So it's a nice fresh look at this, and this has been a popular sort of subject, the VTOLs. In the last few years amongst the community, people wanting to do their VTOLs. So I'm going to take on what we've learned from sort of customer feedback and their attempts to say do a VTOL, and to my approach, and hopefully give you guys some ideas as to what you would build. So we've got in front of us the MFA Fighter. So that's Make Flight Easy. They're the company that originally brought out the Believer, so that's hand-launched twin-engine plane. That's still an amazing aircraft today. And this was their first dedicated VTOL. They did do some modifications to a Believer to make that into VTOL, but this is their first sort of from scratch VTOL, and it is a 2.4 meter wingspan. It can carry 1 or 2 kilos if you want to do mapping cameras, stuff like that. It's a really good, it's a nice, in my opinion, it's a nice size of VTOL. So my opinion may differ to say some of the hobbyists wanting to use smaller frames, but I find when you're sort of around a 2 meter mark and above, you can use them in much more weather conditions. They'll take a bit more wind, or you can put something useful in them. So it's a good size. It's a good size VTOL aircraft for training and also carrying out missions, however, whatever you want to do. So when I first built these aircraft, I would make quite a lot of sort of layouts inside, say using carbon fiber, and I would make a sort of internal structure where I would put all this equipment. So what I'm trying to do this time is we're going to take a fresh approach to that and look at what can we do differently, hopefully with some different bits of technology. And some of the bits would say be slow milling carbon and constantly changing it. So I think we'll do a lot more 3D prints on this using the sort of new printers we've got. We'll also visit the wiring again and see, should we change our PDBs and power monitoring, and again about sort of cable management. So I like to bring all that in and show why we make certain choices. So for today we're going to do a little rundown of what equipment we've picked at this point, and like I say, this might evolve over time. So what we've got first is we have a kit, so the Make Fly Easy Believer kit, fighter kit, sorry. This here is an example of our past ones at the stage we get it to, so it's a laminated and it's a painted finish. And then we've got a selection of electronics here that we've chosen. So let's go through some of this kit and why we've chosen it. Flight controller, obviously most people know me, will put a cube in it. So the current cube is the Orange Plus, so a H7 processor. For this type of and size of model, you know, that's a no-brainer to me. That'll go in there. So that is their latest version. It can run all the full versions of all AudioPilot. It's not a sort of some of the smaller, lower cost ones you have to miss features out. But the H7 boards will run everything. It's also the nice form factor, so the full size cube with plenty of space to plug bits into. We're going to go with the HERE 4. So that's a F9P GPS, but it also has a really good compass. It's got the RM3100 compass. So that's a nice combination. For the series, we might look at a few different control options. So initially, we're going to put in the HERE Link. So the HERE Link is a digital transmission system. So it has video, it has control over the sticks, and it has a telemetry feed to the screen, which we can also sort of link to a laptop to do all our settings, to load missions. So to me, it's a nice workflow. It'll allow us to put a small camera on it. But we'll also look at connecting up a sort of standard setup of a hand controller and a telemetry radio, which that equipment won't give us a video, but it'll give us an alternative way to sort of use the vehicle, which is also in sort of high demand that people use. Let's have a look at some of the other electronic parts we put in. So simply the servos, these are an easy choice. We go with the recommended servo, which is what was in the previous models in the Believer and all them. So it's an Emax 3054 Metal Gear digital servo, about 17 grams, 20 grams. What we sell quite a lot of these servos and we use a lot, so we've had them made with various different cord sizes. So the standard's 25 centimeters, we've got them up to 60 and maybe even 80, and all that does, that allows us to not put unnecessary joins in the servo wires. There is, on this particular model, underneath is actually a parachute hatch, which we've never used. So we do use the servo to close that, and it's kind of just in there because it fits. So that's a ES08 MD2, and that's more just a glorious catch for us. It is convenient for other equipment. Some people might put their radios, transmitters in there, or whatever they're carrying. We then have our sort of power train. So we've got a front motor. Now, we also have what the factory call a PNP version. It is not assembled in any way, but it's the kit plus factory electrics. Now, they use a combination of T-motor and Sunny Sky motors. Now, the only issue, we do get a reasonable stock of factory PNP kits in, but we do have a big delay between restocking. So we have a selection of components that we would use anyway, which are more readily available than the factory stuff, which comes by sea and takes several months. So our power setup for this one is basically all T-motor. We have a front motor, so in this case a AT series, that's a 4130, and we actually had some of these custom made at 200 kV. That allows us to spin a big high-pitched prop. So on a VTOL, you don't need the sort of take-off power that you might have on a wheeled launch, or the sort of need for thrust on a hand launch. You can get away with a higher pitch, more efficient prop because your sort of transition is easier than a traditional launch. That will be coupled with a T-motor Flame ESC. There's a few other choices we can use for the fixed wing ESC. We don't need a BEC on this, so I don't use I choose to use Opto ESCs for the front motor because we're going to do our power for servos differently. Then our lift system. So here's an example of a arm from the fighter, and these have got an arm set on. Again, this is one that we sell, we've had custom made, and that's based on the T-Motor 6007s. So that's the anti-gravity series here, the 6007, 160 kV. And for those of you that haven't seen some of the other videos, an arm set is the nice bracket. So here's an example of a manufacturer's one. It has the ESC inside of it and the motor screwed on. So this comes as one piece for the ones we use. They are hard set in the direction of rotation, so this one looks to be more counterclockwise. And these particular ones have an LED underneath. It's not really necessary, but we do sell these components separately. And to give you an idea, this is a manufacturer's ESC, and this is what would be inside their arm mount. So if you buy the manufacturer's PMP kit, you assemble this, and that's what it looks like, the ESC specifically shaped, and then your motor on top, you set your orientation. So those are the different choices we have. One thing that is difficult, you don't really want to just buy a separate cased ESC for the lift motors, because mounting that will, there's no pretty place to put it. It's going to either be stuck underneath, you're going to cut holes in the foam. So you want an arm set of some description, be it the factory one or be it the T-Motor one. We couple these with the 20-inch propellers. Now we have factory 20-inch propellers, and we also have, in this case we're going to use the glossy, the T-Motor G20. And we're using that one because it's the highest pitch of the 20 inches we have in stock. So this is a 6.5 inch pitch, and some of the versions are 6 or 6.2. So the glossy is quite a nice match for this. So next, a few other things we will add for a VTOL. Now, a VTOL like this must have an airspeed sensor. So the airspeed is extremely important in the transition phase. We do have space to fit 2 airspeeds in this one. There is channels in the wing, so we will, for the sake of demonstration, we're going to fit 2 airspeeds, and we're going to show you how we set those up and why we do that. Airspeeds, if when they work, they're amazing, but if it's obstructed and giving misreadings, in the past that would be catastrophic, but there is now lots of ways that ArduPilot will dismiss a bad airspeed reading. Having 2 airspeeds allows you to sort of continue uninterrupted at the best way if you have a failure, if something loses power or becomes blocked. So in this one, it's a very simple addition to add the second airspeed. We will also add a LIDAR. So there's a few reasons why having a LIDAR on a VTOL like this is recommended, or I would put one on without question. The first thing, if you're doing an automated landing, now that might be because you've done a mission, or you're doing an RTL, lose signal, whatever, it comes home. When a VTOL transitions, it then comes to the ground like a copter, and it starts off very fast, and then it wants to slow down when it approaches the ground. By default, that might be done by terrain, or it might be done by the barometer really. And if you've been flying for a long time, you can get barometer drift, and the worst case scenario would be that it comes into the ground very fast or at a speed which causes damage, instead of at the slowest speed when it knows the height. So just by fitting something like a TF Mini Plus, which has an outdoor range of up to 12 meters depending on light, that allows it to come down at a faster speed, and then you might say when it gets to 2 meters, let's slow down. And that gives you it doesn't waste your battery. It gets it down quick in the most power consumption phase, which is when it's as a copter. There's another nice feature in the latest firmware, which is how it uses the front motor when you're in the copter state. So what happens now is it will use the front motor to sort of hold its position. So instead of tilting over a lot, and it will also use the front motor if you pitch forward. So if you want to move the VTOL forward when it's in the copter state, it will pull itself forward with the front motor, and this is a really efficient way to do it compared to a multi-rotor that would tilt its whole body over. And what we want with that is we want the LIDAR to know when it's a safe height to start doing that. So yeah, a LIDAR on something of this build is a no-brainer. As we go through our component selections, we're also going to bring in some ones that are available but we're not going to include. So one thing we use on other models is a heated pitot. This has the airspeed sensor in, so a lot of people just refer to any part of the airspeed system as a pitot, but what we've got here is we have a heated tube which also has a drain, so it's very good for flying in the bad weather conditions. And then on this particular model it has the 5525 sensor built in, and this is a CAN device. Now at the time of doing this video we are just about to receive the second version of this, so we'll try and feature this in a later video. Now for this aircraft and the purpose that we'll be flying it for, so training flights, it's not necessary to have this airspeed. It would also be a little bit sort of obtrusive on the wing. This is meant to be mounted inverted, but also it wants to be in clean air, so we can't put it at the back of the wing, it needs to be at the front. So it's going to be a little bit bulky on this model. It could be done, but for our use, we're going to miss that one this time. We also, some nice features in the advancement of the ArduPilot code, we want to add some more sensing equipment on so that we can take use of some of the nice tuning features and of notch filters. So you want to accurately know the voltage for definite, and then we also would like to see current. So in the past I've built this, I've normally used a Mauch current sensor. So to give you an idea of the current on this plane, this is 12S, and in hover it normally pulls no more than 40 amps. When it's in forward flight it's 5 to 8 amps. But there is obviously fluctuations within that, so in the hover stage, in sharp acceleration and transitioning, they might go to 50 or 60 amps, but it would be very unlikely to sustain anything over 100 amps at any period of time. So that gives you an idea of the sensor you would use. So we used to use a 100 amp Mauch sensor. What we've got now is we could use this nice CAN sensor. So this is a Matic battery monitor, so it passes through fairly accurate pre-programmed settings, and it can be put on CAN, which allows positioning of this to be very easy. There is other options. There is power distribution boards that have built-in sensing. So I just had a quick check of the specs on this. This is a sort of max 200 amps, and I think it's 60 amps per connection, which is well within tolerance. What we used to do previously, we just needed a sort of solder terminal to sort of connect all the wires together. So we used to use just a dumb power board that is simply copper terminals, and then we put inline current sensing from the Mauch products. So we're sort of going to finalize what system we're going to use here, and then we're going to try and make a nice little 3D printed case for it, and then release these files so that you can, if you are going to build this one, you can use the same parts we've used in the build. So that's a rough idea of the electronic components we've selected at this point. But like I say, some of these might change as we do the final build, and if new products come out that are more suitable. Okay, so let's take a look at what we see in front of us now, this orange contraption, and why is it like this? So this is a traditional, if it was a fixed wing, it's fairly traditional style. We have a front motor, we have a T-tail, and then we have our nice wings here. And what's happened is we've got what I would just refer to as VTOL arms. So these are located on a wing, and what you used to get is a lot of people would modify an aircraft and just stick bars on it and have the motors on it, and you can make a nice sort of VTOL conversion. But one thing that happens there is with the VTOL arms on the wings, there's a lot of sort of torsion and twisting. So quite simply on the fighter, what MakeFly Easy have done is you've got this very stiff lamination. So this makes it nice and rigid, and you don't see as much body twisting. There's still some, but it's at a very acceptable level. What we do is we also laminate the wing. So we do this for stiffness, but also, these foam planes, when you're handling them, you can get damage. You might call it hanger rash. So just by adding this iron-on laminate, it's the same sort of stuff used to laminate posters and paper. We just use a very specific thickness. It gives a nice rigidity to the wing, but it also makes them last longer. We've also used our plastic dip paint, which you might have seen in other videos. One recommendation for this, which we found out after, you're supposed to paint it white underneath for these fluorescent colours. You'll use a lot less paint. So we use a white plastic dip, then we go over it. It still takes 3 or 4 coats to get a nice colour, but this is so visible in the air. It's really good for these training aircraft. It gives you an idea of the shape, orientation of the aircraft, so it's really good for a sort of a training aircraft. And we've highlighted the nose and the tail again. The body's laminated, so we do as much of it as we can. There is some of the curves are too much, like around the nose, so we don't go that far. It looks horrendous. The foam features are standard parts of the kit, so the paint and lamination isn't standard. We do that after. And what we will then look to do is, there's lots of very good sort of module bays and positions for mounting hardware, but we find that we need to do a few little additional parts that we'll print, like a nice housing for the GPS and where we're going to house our power distribution. What we'll also do is we'll have a look at some of the common uses of this. So here's a nice foam mount for a Sony camera. So this would take the A7s and A6000s. So the main purpose when the manufacturer bought this frame out was as a mapping platform, so to carry a downward facing camera. Now looking at this mount now, we have available a few newer cameras, some smaller. So it would be a nice opportunity to show you fitting the sort of latest model of camera and lens to this. We've got nicer integration now with some of the cameras and autopilot, so we'll be able to show you the sort of latest recommended setup as a mapping platform. So I hope that shows you a nice overview of the kit we are going to build, and also the products we've chosen to go in it, the electric setup, the control setup, and gives you an idea why we've chose these. So these some of these have been a very good product to use over the years, and then we're also going to change them to what's modern and most available. So join us in the rest of the videos where we're going to go through flashing the cube. We're going to set up what does what and connect all these sensors, tell it it's got a LIDAR, and then we'll start to work into the final assembly and also look at tuning and flying, making the first flight with this aircraft. So between now and the next video, I need to get out my favourite Yoo-hoo paw and start gluing this all together, because we'll go through several tubes of this, but this is the recommended glue to start assembling this kit. So I hope to see you next time.
Thank you for watching my video. Check out the playlist, and adding Pedantry 60 to your search terms will help you find my content. If you haven't done so already, please hit the like and subscribe button. It helps a lot. You can support the time I spend here answering questions and helping others by using the links in the video description.